Hello my dear students, a warm good morning one and all. Myself Mr. Suresh Kumar, I am a IIT facilitator for mathematics. In this video, we are going to discuss a new concept, okay, which is very more important application for JEE mains as well as advanced. Okay, let us move to the topic. It is none other than conic section. Okay, it's none other than conic section. Today I am going to teach you conic section. Let us go into the introduction part. What do you mean by conic section? Okay, very simple word. It is nothing but section of a cone. Okay, the section of a cone is considered to be a conic section. Alright everyone, the section of a cone is considered to be a conic section. I mean, you know one thing, actually in general very easily we can going to mention about the conic section. There are the curves intersected by a right circular cone intersected to a right circular cone by a plane. Okay, then the curves express as follows. In that case, the first one is circle, and the second one is parabola, and the third one is ellipse, and the fourth one is none other than hyperbola. Hyperbola. Okay, let us see. We would like to show the degenerate conics now. Okay, coming to the degenerate conics means, first of all, please draw a double napped cone. Means I would like to draw a cone here. Just I am going to draw a double napped cone like this. Okay, I have drawn a double napped cone. Okay, how it exhibited before, how it has been formed like this. Okay, the both point of intersection we call it as vertex. What do you call this one? Vertex. And this upper cone is considered to be this one, upper nap, and which is being considered to be a lower nap. Okay, you know one thing that now we are going to draw one perpendicular. We are going to draw one perpendicular like this. Okay, this perpendicular is considered to be a fixed line. This perpendicular is treated to be a fixed line, and you know one thing, where the both, whenever this line and this one intersect each other, it becomes an angle alpha. Where it makes an angle alpha. How it happened before? Let us see. Actually, the thing is, now I already drawn this black line. This black line is named as L. Okay, L in the sense which is we consider to be a fixed line. This L is treated as a fixed line. Okay, and there is a one line which will be revolve itself. There is a line which is revolve itself. Okay, you know one thing, this line revolve around the fixed line, and it forms a cone. What type of cone it is? Right circular cone. Okay, it revolves around itself, we call it as generator. We call it as that line we treated as a generator. Yes. How we understand what do you mean by the actual how the double nabble cone has been appeared through the fixed line. Okay. You know one thing, that given fixed line is also known as the fixed line. Here we call it as a directrix. Is it clear, guys? We call it as a directrix. Yeah. Now let us move to the brief observation. Let us move to the brief observation of each and every conic. I would like to show you here. See, if there is a now. Actually, you people all know one thing. The thing is, a cone is a 3D figure. Yes, but here in the coordinate system, we are going to show whenever a plane intersects a cone. Okay, it exhibits four important curves. They are circle, parabola, ellipse, and hyperbola. How it will be happen? Just okay. I just took one plank itself. Okay, this is a two-dimensional figure. Okay, it is a surface. Now I just see now whenever a plane. See guys, exactly. I just keeping perpendicular to the fixed line. I just mentioned this perpendicular. Okay. Okay. I have to let me draw here. See guys, I have been drawing. Means this is the intersection of a plane, guys. This is the intersection of a plane. Means plane in the sense I already told, right, which is in a surface portion. In this way, what will happen? It is a plane cuts the right circular cone at an angle 90 degrees. We call it as a beta, which is equal to 90 degrees. Okay. At beta equal to 90 degrees, what did you have been observed here, Nana? See, whenever a plane cuts this portion in perpendicularly, it obtains one simple closed figure. It obtains a simple closed figure. I mean, in the sense, let me show you like this. There is a plane which, whenever after cutting itself, it forms one simple closed figure that is none other than circle. That is none other than circle. Yes, what we call it as circle. At angle beta equal to 90 degrees, it forms a circle. Hope you understand. And the next, okay, and the next. The same cone again we are going to take. The double nabble cone we are again going to consider. Again we consider a double nabble cone. Okay. In this, through we are drawing one perpendicular in the same manner. Okay. The thing what will happen now? Now the same cone cut by a plane at an angle which is at an angle guys, I already briefed you. See, the fixed line and the moving line makes an angle alpha here. What about now plane has been cut like this? Okay. Now it has been cutting the cone itself. It forms a usual figure like this. Okay. Where you know one thing that here alpha is less than beta in this case. Okay. And which is less than 90 degrees. Got the point, guys? In this case, one of the simple closed figure has been mentioned, which is in oval in shape. Now examine. This is a now plane has been cut the chord itself. It obtained this shape. This shape we consider as ellipse. What we consider Nana? Ellipse. We have to consider to be it is as ellipse. Okay. And next, two more diagrams are there to mention now how it will be. It is a little bit difficult task, guys. I brief you how to mention that diagram with a careful manner. Okay. Again and again. Again the same double napped cone we have been choosing. See, for each and every diagram we have to mention. Okay. We are drawing on perpendicular. Okay. Which makes an angle alpha. Okay. Now let us see, guys. Now through this point itself, through the point, we are drawing one now. We are now drawing a plane. Here we have been drawn one plane itself like now. Okay. Okay, here it makes an angle beta, and while cutting itself we obtain one closed figure here. Here we obtain one closed figure, that is nothing but after cutting itself one parabolic form will be appear. Means a plane whenever it cuts itself, then we get a U-shaped curve. It is none other than parabola, which we consider to be a parabola. Hope you understand, guys? Which is treated to be as a parabola. Okay. By the way, the next. This is a little bit difficult task. Let me show you that one. Okay. Now for a double lapped cone, again for a double napped cone, okay, for this cone again which makes an angle alpha, and you know one thing that now I already brief you, a plane cuts to this point itself, we got one parabolic form in upper nap, and one more parabola form will be appear in a lower nap. I mean that, see, now it cuts like this. Now whenever it cuts like this, exactly the given fixed point itself. Okay. The plane which cuts this part, the plane which cuts usually, the plane which cuts its position carefully. Okay, whenever it cuts this position here, where it makes an angle beta. Okay, then it forms one U shape in the upper lap and another U shape in the lower lap. We call it as hyperbola. What do we call this one, Nana? Hyperbola. Okay, we now dividing the plane in these sections we consider to be a degenerate conics. What we call them? Degenerate conics. Okay, guys, and let us move to the basic definition of a conic now. And apart from that, we know what do you mean by parabola, what do you mean by ellipse, what do you mean by a circle. Okay, what do you mean by hyperbola, what do you mean by a circle, how it will be appeared. Okay, with simple definition. Okay, and in this session, after I would like to teach you equation of parabola in standard form. Okay, why? Because this is the coming to the conic section. See, every application is more important. We have to give so much priority for this subject. This concept. This chapter involves many applications, miscellaneous questions, and moreover, we can easily handle all those things carefully. Yes, and next let us move to that. And one more, last but not the least, here. Last but not the least, if alpha equal to beta, means if alpha and beta are equal to each other, you know one thing, that it forms a straight line. It forms a straight line through vertex. It forms a straight line through vertex. Okay, exactly. Okay, Nana? Let us see. Sorry, it is not through vertex. It is a generator. Okay. Next, let us move to the definition of a conic. Okay. Very important notation, Nana. See, we already briefed you before. Here, alpha be an angle which is made by a fixed line, and its generator means the moving line. Okay, and beta be an angle obtained by intersection of plane. Obtained by an intersection of plane, after intersecting a plane. Okay. Next, here the important things. If alpha equal to beta, then it forms a parabola. But sir, before you have told, if alpha equal to beta, means the thing, what is that? The meaning of alpha equal to beta here, let me tell you the thing. A plane contains a generator and its section will be considered to be a straight line. Okay, that's what I told before, like that. And coming to the next, if beta equal to 90 degrees, that figure forms a circle. And the third case, if alpha angle is less than beta and which is less than pi by 2, then this figure obtained as an ellipse. Okay, and the fourth, and where 0 less than or equal to beta less than alpha, this figure we consider to be an hyperbola. What do we call this one? Hyperbola. We call that figure as hyperbola, isn't it? Yeah. Let us move to the next definition of a conic. Let us move to the next case. Definition of a conic. Definition of a conic. Definition of a conic. Treat this L equal to 0 be a fixed line. This fixed line we call it as, what we call this one on this fixed line is called as directrix. What do you call this fixed line, Anna? Nothing but directrix. Okay. See, Nana, we are drawing a perpendicular. Okay, where it intersected point P here. Okay, this is M. You know one thing? Here M is a projection of P on the fixed line. The fixed line we call it as a directrix. Okay, and the next there is a fixed point S here. Okay, now we joined P and S. Okay, you know one thing that we call it as alpha beta. For better understanding purpose, now I am taking this fixed point as alpha comma beta. This P as x1 comma y1. Okay, M I already briefed you, which is a foot of the perpendicular. Projection in the sense foot of the perpendicular only. Okay, guys. Okay. Now we have to write down the definition about this figure. How it will be happen? You know one thing. See, the locus of a point in a plane. The locus of a point. Where is the locus of a point here? P x1 comma y1 be a locus of a point in a plane. Okay. Whose distance from a fixed point, whose distance from a fixed point to the distance of point P from a fixed line, bears a constant ratio. Okay, bears a constant ratio. I mean, what I am going to say here, SP over PM equal to one constant ratio, that is none other than E. Okay, SP by PM, which is equal to E. What do you mean by E here? E in here E is treated as a constant ratio. Its name as eccentricity. What we call that one? Eccentricity. Hope you understand. That is considered to be a eccentricity. Okay. Let us see. Let me mention that one. Okay. The constant ratio E is called eccentricity of a conic. Okay, and next, the fixed point S is called, the fixed point S is called focus. Okay, and next, the fixed line, I already briefed you, the fixed line is treated as directrix. The fixed line is treated as directrix. Okay, and one more important thing, Nana, you have to know about complete brief information of a conics with especially it's completely depends upon eccentricity. Eccentricity value on the based on eccentricity value we can easily identify it is a okay, it would be a parabola, ellipse or hyperbola, and one more conic is there, that is also none other than rectangular hyperbola, which is coming to the hyperbola family of course. Okay, let me mention you. Okay, at E equal to 1, the conic is a parabola. The conic is treated as parabola. At E less than 1, the conic is an ellipse. Okay. At E greater than 1, the conic is a hyperbola. The conic is a hyperbola. And at E equal to root 2, the conic is called a rectangular hyperbola. What do we call this one? Rectangular hyperbola. Do you all catch up my point, guys? These are the very most important things to identify which type of conic it is. Okay. By the way, now in this session I would like to discuss about the standard form of a parabola. Okay, equation of a parabola in standard form. I would like to show the derivation for you there, guys. Let us see. Wiping out completely the board. Okay, I forgot one thing, that I have been drawn SP by PM equal to E, right? SP by over PM. I have been mentioned, right? SP by PM, which is equal to E, in the sense SP equal to EPM. Here I already told S is a fixed point we consider to be alpha gamma beta. P is a moving point locus x1 gamma y1. M is the projection of P from a fixed line, that is none other than directrix. Okay, we call this fixed line as directrix. Okay, we call S as focus, and P is a moving point. P is treated as a moving point. Alright, SP by PM is equal to E. In general, actually as per the definition of conic, how this equation will be obtained for second degree case, let us see. The thing, see, SP in the sense distance between S and P. What will happen? Distance between P and S. What will happen? X1 minus alpha whole square plus Y1 minus beta whole square equal to E into perpendicular distance from P to the directrix. Guys, if you are unable to understand the definition of conic, this is a simple task to identify. How? You know one thing, the ratio, definition of a conic in simple words, the ratio of a distance of a point from a fixed point to its perpendicular distance from P to the directrix. Distance of P from a fixed line also it is treated. Okay, in our own words also we can easily write down the definition of a conic with the help of this identification. Got the point? Yeah. Now see, I would like to treat the fixed line directrix as ax plus by plus c equal to 0, or for in general we can also mention as lx plus my plus n equal to 0. Whatever may be, that is your wish completely. Guys, that is your wish completely. You can consider with ax plus by plus c equal to 0, or else lx plus my plus n equal to 0. That is completely your wish. Hope you understand. Then let us move to the next level. Okay, after on squaring both sides, what will happen? Okay, it will happen x1 minus alpha whole square plus y1 minus beta whole square, which is equal to e square, and I already briefed you, perpendicular distance from point P to the given line, which is nothing but ax1 plus by1 plus c whole square by root a square plus b square. In the sense it becomes a square plus b square. Okay na? This is the okay. This will be the required locus nana. This is the required locus x minus y. The locus of P I am going to write here, x1 minus alpha whole square plus y1 minus beta whole square equal to e square by a square plus b square times of ax1 plus ax plus by plus c whole square. Okay, do you all catch up my point? Yes. Now let us move to the equation of a parabola in standard form. Now equation of a parabola in standard form. Let us move to the equation of a parabola in standard form. Okay. Equation of a parabola in a standard form. Equation of a parabola in a standard form. Okay guys, I have been drawn one parabola. Okay, the U-shaped curve I consider like this. Okay, now this is a fixed line. We call it as directrix. Before going to discuss this, how it has been obtained, okay, I will show you a figure very easily. Okay, mention the fixed line like this. Okay, now what about the distance of P from S? Gradually same, they both are same distance, they are mentioning the same distance. See, now this point has been moved here, the P has been moved here. Okay, but S in the fixed position. Why? Because it is a fixed point. I have been drawn like this, and I have been drawn on perpendicular. You know, now this distance is same. Now P has been moved here, and it has been moved here. Now P has been moved here. Now perpendicular have been drawn here. Means, see, here M is not a fixed point. Here M is not a fixed point. Okay. Here S only the fixed point, but it is a fixed line. In a fixed line, we can easily mention infinite number of points here. It can intersect like this. And again, see, if I extend the fixed line, okay, now the P position here, okay, and again it intersect here. Now the P position is here, and again have been intersected here. Okay, now joining these points, moving points, what do you receive now? What do you receive after joining these all points? Okay, mentioned as P1, P2, P3, P4, P5, P6. It forms a curve which is in the shape of U, is treated as parabola, is named as parabola. It is a parabola has been obtained like this. Okay. By the way, now we are going to the derivation of a parabola. First of all, consider a fixed line. Okay, there is a fixed line, and this is now through this point we are drawing one. See, this is considered a coordinate system, guys. X dash, y dash, which we treated as equation of direct space. Come here to here, and this is a fixed point S. You know one thing, this vertex is named as A, and this is treated as Z. This point treated as Z. Okay, you know one thing. Okay, and P has been fixed here. Through P, we are drawing one perpendicular, that is M, and joining S. Okay, let us see, guys. I would like to explain this one. Here we call S is a focus of parabola, which is appear on x-axis. Okay, I would like to treat it as a comma 0. Okay, A is a vertex. A is a vertex of parabola. A is a vertex of a parabola, means which is a point lies on parabola. Which is the point which lies on parabola. Okay, and the next P, x1 comma y1. I already briefed it is a moving point. Okay, now you know one thing, that S is a comma 0. You know here A treated as A is the midpoint. A is the midpoint of SZ, that is length of SA is equal to AZ is equal to small a. AZ means SA length small a, AZ length is small a. If it is a comma 0, what about Z nana? It becomes minus a comma 0, and this vertical line is vertical line. Let us see the vertical line. This vertical line is parallel to y-axis, means equation of a line parallel to x-axis. Already we know that is x equal to k. Means this equation of a line parallel to y-axis is called x equal to k. Here k value how much? S value how much? Sorry, the value of x value is equal to minus a. That's why we call x plus a equal to 0. Okay, x plus a equal to 0 be a directrix. Okay, which is denoted with L, equivalent to L. Okay, L equivalent to x plus a equal to 0 be a directrix. Now in simple general words we are writing. Okay, and M comma Z are the projections. I mean, projections or foot of the perpendicular, both are same meaning. Okay, both having same meaning. Projections of P and S on projection of P and S on directrix respectively. And the next, the case after the next, what we are going to discuss now. Yes, already we have been briefed everything and have been mentioned each and every step, and let us move to the next level. By definition of conic, okay, SP by PM equal to E. Guys, I already briefed you if eccentricity equal to 1. If anyone asked the definition of a conic with eccentricity, a conic whose eccentricity is unity is called a parabola, or a conic with eccentricity 1 is called parabola. You can say anyway. Okay, means I am treating E equal to 1. That implies what will happen? Length of SP is equal to 1 into PM. Okay, the distance between S and P, what will you receive, Nana? x1 minus alpha whole square. Next, y1 minus 0 whole square. Why? Because a comma 0 is a point on x-axis. Okay, and here forgot to tell one thing. Here A is a midpoint of S and Z. I brief you. If it is plus a, it is minus a. If we done midpoint means what you get a na? Here A has been treated as origin. Here A treated as origin. Why? Because it is a point of intersection of both x and y axis. We already know that it is a point of intersection of x and y axis, which is treated as origin. Yes. And next, x1 minus alpha whole square plus y1 minus 0 whole square is equal to perpendicular distance from P to the line. I mean P to the directrix, which is equal to mod x1 plus a by square root of x coefficient is 1. That is 1 square, nothing but. Okay. On squaring both sides, what do you receive, Nana? Root x1 minus alpha whole square plus y1 whole square is again y1 whole square is equal to mod x1 plus a whole square. Square and root cancel. x1 minus alpha whole square plus y1 square is equal to x1 plus a whole square. Under modulus plus or minus means it becomes square only. That's why written directly. In general, we are now moving this x1 minus alpha whole square. That side, what will happen? y1 square is equal to x1 plus a whole square minus x1 minus alpha whole square, which is in the form a square minus b square. y1 square is equal to, how can we mention here the y1 square becomes what? A square minus b square. A plus b into a minus b. Okay, plus and minus, plus a minus a cancel. 2x1 into 2a. y1 square is equal to 2x1 into 2a, which is equal to 4a x1. That implies y1 square is equal to 4a x1. Therefore, the locus of point P is treated as y square equal to 4ax, which is known as a standard form of a parabola. Which is treated as standard form of a parabola. Okay, guys. That is today's session, guys. And actually, I already briefed you that. Before going to discuss about a conic section, it is a very vast application. Okay, we have many necessary and sufficient conditions, and we can also compare with second degree equation like ax square plus bx plus ax square plus 2hx plus by square plus 2gx plus 2fy plus c equal to 0. Okay, is treated to be a parabola, ellipse, hyperbola, and also noted represent pair of straight lines, represent pair of parallel lines. Okay, and next represent pair of perpendicular lines. Okay, these are all applications will also we have some properties based on second degree equation. And not only that, in depth we are going to discuss means we have a tangential conditions, normal conditions of normality, and next about distance between the focus. Okay, and next focal distance. Okay, these are the plenty applications are there to discuss. Okay, in upcoming days. Okay, up to this I am going to stop this session, and thank you for watching, and thanks for encouraging me to do such a good videos. Okay, and upcoming days we receive lot of applications to discuss in our class. Hope you all, thank you for watching.